Hi there, it's Mr. Kim. I'm here to go over a few questions from the exercise that I had for you guys today for the Chapter 8 practice test in Big Ideas. The first problem I'm going to go over is number 12, which asks which infinite geometric series has a sum. If you recall right here from section 8.4, you could see that we have this equation, the sum of an infinite geometric series. And the biggest thing that you need to remember is this piece that I just highlighted, and that's where the absolute value of r needs to be less than 1. If it's not less than 1, then the series has no sum. Also, make sure you memorize that equation right there above. So if we go back to this problem, what you're going to have to do right here is figure out what is the common ratio in these 4 different series. So quite simply, let's go ahead and take with the first one, we got negative 2 divided by 1, that's going to be negative 2. But remember, if you take the absolute value of it, it needs to be less than 1. And that's not the case right here. So therefore, that's not a true statement. I'll go ahead and say not true. So because absolute value of negative 2 is 2, and 2 is not less than 1, so that first problem or first selection is no good. So then let's go to the next one. Let's take 1/2 and let's divide this by 1. Remember, when you divide, you go ahead and multiply by the reciprocal, which is going to be 1/2 times 1 anyways. And so this right here is going to be equal to 1/2. I take the absolute value of it. Is that less than 1? It sure is. This is a true statement. And so that tells me that that right there is the actual answer. If we just go ahead and try the rest of them, negative 1 divided by 1, that's negative 1. But the absolute value of that is not less than 1, so we're going to say not true. And then finally, if I take 1.2 divided by 1, that equals 1.2. The absolute value of that is also not less than 1, so it's not true. So we figure out the one where the ratio is less than 1, and that's when we know the infinite geometric series has a sum. Right. The next problem we're going to take a look at is number 17. So number 17, it says each week you deposited money in a savings account. The first week you deposit $8 in the account, and then each week you deposit 2 more than you deposited the week before. So in these problems, sometimes we have these word problems where we're dealing with interest, or we were dealing with it could be either arithmetic or a geometric series. If each and every week we're depositing 2 more dollars, it sounds like we're adding 2 each week. So for me, that sounds like it's a common difference, and therefore this is a arithmetic series. So let's start off and think, all right, I'm going to be figuring out we have a sub n is equal to a1 plus n minus 1 times d. We want to come up with the rule, okay? That's first and foremost. Some other key information right here. First week we deposit $8. So that should tell me that's a sub 1 is equal to 8. All right, so let's go ahead and start plugging things in so we can come up with our rule. We've got 8 right here for a1. We have n minus 1, and then times our common difference, which is going to be 2. So don't forget, remember to always simplify this all the time. We'll distribute. We got plus 2n minus 2, and a sub n is equal to 6 plus 2n. So we have that now, and the reason why is so that we could figure out, remember, if I want to find the sum, we have a particular equation that we use for the sum of a arithmetic series. And let's go ahead and write that down. It's s of n is equal to n times A1 plus A sub n over 2. Okay, that is how we find the sum of the series. And A1 is the first term, and we have to figure out the last term, right? That's A sub n. Don't forget that right there, last. So if that's my last term, the last term will be 12 weeks. So in order to help us find that, now we can go ahead and use the rule that we have and figure out, well, how much is it that we have, or what is the amount in 12 weeks? So we'll go ahead and put A sub 12 for 12 weeks. And we got 6 plus 2 times 12 for n. And so if we go ahead and simplify this, 2 times 12 is 24, plus 6, A sub 12 is 30. So in the 30th week, we have $30 that we're going to deposit. Or sorry, in the 12th week. And so let me go ahead. Let's plug things in right here. For S, we're finding the sum of 12 weeks because that's how much we're saving. N will be 12 for 12 weeks. And then we have A1, which is 8, plus the last term, which is the 12th week. And we substitute that in for 30. And there you go. We go ahead and simplify this out. We've got 12 is equal to 38 over 2. 12 is, 12 times 38 over 2. And then 38 over 2 is 19, so we got 12 times 19. So if we go ahead and multiply that together, the sum will be 12 times 19, which right here should get you 228. And it's going to be dollars. So that's how much we'll save after 12 weeks. The next question I'm going to take a look at is number 19. This one says, the bird sanctuary initially contains 1,000 birds. Each year, 10% of the birds fly away. So the sanctuary is restocked with 40 new birds, and we're going to write the recursive rule for the number A sub n. Okay. I think the important thing to note here is we have to remember that if each year 10% of the birds fly away, what do we have left? And that's what we need to, that's the number that we need each and every term. So the idea here is what ends up happening is some students, what I think where the reason why you do get confused is you'll take 1,000 and you'll multiply that by a rate of 0.10, which is 10%. But if you do that, that means you're only left, what you're getting is 100. Now, you have to think, do we only have 100 birds left? Because each year 10% of the birds fly away. So the idea here is when you come up with the recursive rule, you can't use 10% or 0.10 in your rule. Well, what do we use? Well, if 10% go away, that means we have 90% left. So to put that in the big picture right here, what if instead of 10%, we multiply this by 0.90 or 0.9, and then that equals 900. And so what that tells us now is that we actually have 900 birds left this first go around. Right after the first year, 10% of the birds fly away. That means we actually have 90 or 900 birds left over. So it's important to note right here that in order to get this problem correct, is we have to have the correct rate. And this is having 0.9, not the 0.10. So when we come up with our rule, remember we always start with A1, which is going to be the initial amount. That's 1,000. So that's probably most of you got that one correct. So then for our rule, we have A sub n And that's going to be equal to, let's think about the number that we have, or the rate, and we're going to have 90%. So we're going to go ahead and put 0.9. You could put 0.9, and then we're going to multiply that by the previous amount, right? A sub n minus 1. So that's going to tell us, all right, we take 90% of each time. But remember, we do restock the birds, and we restock with 40 new ones, so we're going to go ahead and put plus 40. And there's your rule. If you think overall, does that make a little bit more sense? I would think it does, because you think after the first year, if we take 1,000 times 0.9, or 90%, and then we add 40, we have a total of 940 birds. So in the year after, what ends up happening right here is this. I have my 940. I'll multiply that by 90% because 10% disappear. So if I take 940, multiply that by 0.9, I now have only 846 birds left, but we restock it with 40, getting us now to 886. So you can see by doing it this way, we take away, or we multiply it by 90% because that's how much we have left. We'll be able to get the correct rule for this problem. If we take a look at the very first part right here where we multiplied it by 10% and we left with 100, if we were to add 40 to that, that means we only have 140. Yeah, but that's not that many birds, right? That's way too many birds being gone. So hopefully you can now figure out the difference on when to multiply by the actual rates that given to you, or maybe the other side of it where you take 1 minus that rate. And realistically, it just depends on how the problem is put together. All right? You got to really be careful with how you read it and conceptualize what is the number or the previous number that I'm going to need to have to successfully solve this problem. All right, so hopefully this helped you out. And don't forget, we do have a test coming up on Monday.